Good afternoon. Am I audible? Or you can just- Okay. Let us start our class today's class. Now, before going to start the today's class, whatever we have done in the last class, just I revise. In the last class, that is on Friday, we have completed the first order and first degree differential equation part. And after that, we have started the second and higher order linear differential equations. In the second higher order linear differential equations, we have written some definition. That is, first we have started with nth order linear differential equation general form. Next, its operator form. After that, auxiliary equation, characteristic equation. Next, general form of the general solution, and then we have written the Ranskin. After that, we have written the procedure for finding the general solution of homogeneous linear differential equation. Now, to find the general solution of homogeneous linear differential equation, the general form of homogeneous linear differential equation in operator form, that too in short form, is f of d y equal to 0. And non-homogeneous equation is this, and this is the homogeneous linear differential equation in short form, that too operator form. It is non-homogeneous linear differential equation, and this is homogeneous linear differential equation. Its general solution is written as y equal to yc. Complementary function is the general solution for homogeneous equation. For a non-homogeneous equation, general solution equal to y equal to yc plus yp. We can obtain the yc or complementary function from the homogeneous part of the differential equation. In the non-homogeneous equation f of dy equal to q of x, this is the homogeneous part, and this is the non-homogeneous part, because this right hand side is free from dependent variable y, free from its derivatives, and the left part will contain the derivatives and also dependent variable. That way, this is a homogeneous part, this is non-homogeneous part. From the homogeneous part, we can find the yc. From the non-homogeneous part, we can find the yp, and then we can get the solution as yc plus yp for non-homogeneous equation. But for homogeneous equation, only y equal to yc. Yc is the complementary function. And to write the yc, already we have written the procedure. From this f of dy equal to 0, first we write the auxiliary equation f of m equal to 0. We solve it for roots. Depending on the roots, we write the yc on. That is a complementary function and also general solution of homogeneous equation. After that, we have done one problem. That is, we have taken the first problem as previous gate question. That is 2020 question, 1 mark question of EC branch. Next, its continuation, problems on homogeneous linear differential equations. Problem number 2. The general solution of y double dash minus 4y dash minus 6y equal to 0 is. In this given differential equation, highest order derivative is second order. Therefore, it is a second order differential equation. And every term is containing the dependent variable y and its derivatives. So it is a second order homogeneous differential equation. Throughout the differential equation, the power of the derivatives is 1. The power of the dependent variable is 1. There is no product of y its derivative. Therefore, it is linear. Second order homogeneous linear differential equations. The general form of the second order linear differential equation is like this: d square y by dx square plus P of x dy by dx plus P of x into y equal to Q of x. It is a second order linear differential equation, general form only. P suffix 1 of x. This is P2 suffix of x. P1 of x is coefficient of derivative. P2 of x is coefficient of y. P1 of x, P2 of x. These two are coefficients in the differential equation. These two coefficients may be constants or functions of x only. These two may be constants or functions of x. So based on these two, the differential equation is called linear differential equation with the constant coefficients or linear differential equation with the variable coefficients. Suppose P1, P2 are constants, these two coefficients are constants, then the differential equation is called linear differential equation with the constant coefficients. Out of P1, P2, any one is function of x or both are functions of x, then the differential equation is called linear differential equation with variable coefficients. Linear differential equation with variable coefficients. And repeating, P1, P2 are constants, then differential equation is called linear differential equation with constant coefficients. Suppose P1, P2 are functions of x or any one is function of x, then the differential equation is linear differential equation with variable coefficients. Functions of x, variable coefficients equation. Constants, then constant coefficients equation. That's it. In the given differential equation, our coefficients are in place of P1 of x minus 4, in place P2 of x minus 6, constant. Both P1, P2 are constant. Therefore, the differential equation is linear differential equation with constant coefficients only. Now, we have to find the solution of this equation. Because of the homogeneous equation, finding the general solution is same as finding the YC only. According to our procedure, first you have to express the given differential equation in operator form when it is not in operator form only. Our equation is not in terms of denotation, therefore it is not in operator form. We try to write this in operator form. To write the operator form, we replace the y with 1, y dash with dy, and y double dash with d square y like this. So that we can write the equation in terms of d1. Directly we write the operator form in short form. Given f of d, y equal to 0. So this 1, comma, where f of d equal to d square minus 4d minus 6. This is a given equation in terms of operator form, that is short form. Next, consider auxiliary equation f of m equal to 0, which implies m square minus 4m minus 6 equal to 0, which implies it is a quadratic equation. If we solve it for roots, then we get the two roots. The roots may be real or complex, may be repeated, may not be repeated, maybe surds also. For general quadratic equation, ax square plus bx plus c equal to 0. The roots of this equation are given by x equal to minus b plus or minus under root of b square minus 4ac by 2a. So we can use this formula. If it is possible to write the factors, we can write the roots directly. Not possible to write the factors, then we can use the formula. Or for anyone, we can use the formula also. So after simplifying this, we get the roots as like this. 2 plus or minus under root of 10. 2 plus or minus under root of 10. These are real because no imaginary root. These are real, and also different. Or other way, these two are pair of conjugate sets, a plus or minus root b form only. These two are in the form of a plus or minus root b only, which implies we can write the yc as in terms of exponential or in terms of hyperbolic functions only. C1 e power 2 plus root 10 into x plus C2 into e power 2 minus root 10 into x, or yc equal to, in terms of hyperbolic, from both e power ax is common, that is e power 2x inside some constant into cos hyperbolic plus C2 into sine hyperbolic, like this. This is a complementary function. Therefore, the general solution of 1 is y equal to yc only. In place of yc, we can write any one. Just write the auxiliary equation, solve it for roots, and then write the linear combination. It is a second order linear homogeneous differential equation. The second order linear differential equation will have second order quadratic equation, and from that we get the two roots. Based on two roots, we write the linear combination of two independent solutions. Because of the linear combination of two independent solutions, we have here only two arbitrary constants, C1, C2. So second order solution contains only two arbitrary constants, and third order solution contains three arbitrary constants. In general, nth order differential equation will contain nth order linear differential equation solution will contain n arbitrary constants. In the general solution, number of arbitrary constants is same as the order of the differential equation. That is why for second order only two arbitrary constants C1, C2 in the solution. It is a second problem. So we are going to next page. That is next. The next page we write the next problem. Problem number 3. The solution of y double dash plus 4y dash plus 5y equal to 0 is. Again, it is a second order linear homogeneous with constant coefficients equation, because in place of P1 of x, in place of P2 of x, we have only constants. Second order linear homogeneous with the constant quotients. Now we write the solution. In the solution, first we write the operator form. F of dy equal to 0. So this 1, comma, where f of d equal to d square plus 4d plus 5. Consider auxiliary equation m square plus 4m plus 5 equal to 0, which implies roots. Again, possible to write the factors, and then write the roots. Otherwise, you can use the general quadratic equation formula. Now, after solving this equation, we get the roots as m equal to minus 2 plus or minus I. The roots are pair of conjugate complex. These two are in the form of a plus or minus I, b form only, pair of conjugate. Whenever the roots are pair of conjugate sets, we can write the solution in terms of exponential or in terms of hyperbolic functions. Like that, whenever the roots are in terms of like this, complex, then we write the solution in terms of exponential or in terms of trigonometric functions, which implies yc equal to c1 e power minus 2 plus I into x plus c2 into e power minus 2 minus I into x, or yc equal to e power minus 2x into c1 cos x plus c2 into sin x. Therefore, the general solution of 1 is y equal to yc. In place of yc, we can write anyone, either in terms of exponential or in terms of trigonometric functions. Roots are complex, then we write like this, in terms of exponential or trigonometric functions. This is third problem. Next, we go to next problem. We write that problem in next page. Next, problem number 4. The general solution of d square plus 1 whole square y equal to 0 is option A. In first 4 problems, differential equation was given. Differential equation was given just in terms of derivatives, but here already the differential equation is given in terms of denotation, that is operator formula directly. And now in the solution, given f of d y equal to 0 series 1, where f of d equal to d square plus 1 whole square. Auxiliary equation is m square plus 1 whole square equal to 0, which implies m square plus 1 into m square plus 1 equal to 0. It is a fourth order algebraic equation, and we have written this square as m square plus 1 into m square plus 1, and each factor will give 2 roots. So m equal to 0 plus or minus I, comma 0 plus or minus I. Because of fourth order equation, it will have 4 roots. Out of 4 roots, all the roots are pair of conjugate complex, A plus or minus IB form. Just we are going back to the previous page. On previous page, already we have done one problem with the complex roots. Just look at this. So we can write the in terms of exponential or in terms of trigonometric functions. Like that, here also we write the same thing in terms of directly trigonometric functions. But here roots were repeated only. Here roots were repeated. How many times repeated? Plus I is repeated 2 times, minus I is repeated 2 times. Each root is repeated 2 times. If you observe the first problem in this topic, or on Friday, we have done one problem, and that problem is contained with 2 repeated roots, m equal to 3, 3. In that, we have written the y equal to c1 plus c2x into e power 2x, 3x. Like that, for repeated roots, we write the linear combination. In the previous problem, the solution was like this. E power minus 2x into c1 cos x plus c2 sin x. E power minus 2x into c1 cos x plus c2 sin x. This was the solution for previous problem only. Complex roots, complex roots. But in this problem, complex roots are repeated 2 times only. So we try to write the same solution in terms of like this trigonometric function, but in place of c1 corresponding to 2 times repeated, we write it like this: c1 plus c2x. In place of c2, we write the c3 plus c4x only. It is only difference. Suppose roots are repeated 3 times only. Then in place of this, we write the c1 plus c2x plus c3x square. Next to c4 plus c5x plus c6x square, like this. Depending on roots, number of times repetition, we write like this solution. But here roots are only repeated 2 times. Therefore, the general solution of 1 is y equal to c1 plus c2x into cos x plus C3 plus C4x into sin x. That's it. Into e power 0x. E power 0x is 1, like this. This is a general solution. Only in place of arbitrary constant, we write the linear combination like this. Correspond 2 times repeated roots. The roots are repeated 3 times like this, we write it like this, we write it. This problem is completed. Next, we are going to next page. The next page, we write the next problem. Problem number 5. The solution of y triple dash minus 6 y double dash plus 11 y dash minus 6 y equal to 0. It is a problem. Up to fourth problem, all differential equations were second order. Now it is third order equation. It is a third order linear differential equation. Again, it is also third order homogeneous linear differential equation with constant coefficients. Because of third order, it will have 3 roots. Using 3 roots, we can have the linear combination of 3 independent solutions. Given f of dy equal to 0, series 1, where f of d equal to d cube minus 6d square plus 11d minus 6. It is the equation. Auxiliary equation is m cube minus 6m square plus 11m minus 6 equal to 0. It is a cubic equation. Up to quadratic equation we have, that is, if it is linear equation, directly we can write the solution. If it is quadratic equation, possible to write the factors, we write the roots directly. Not possible to write the factors, we use the general formula for finding the roots of quadratic equation. X equal to minus b plus or minus under root of b square minus 4ac by 2a. But from third order onwards, like this equation, we don't have any particular method for writing the roots of the equation. So in this equation, to find the roots, for this third order equation, to find the roots, by trial and error method, we try to find one of the root. With the help of that root, we try to reduce the cubic equation to quadratic equation, and then we find other 2 remaining roots. To reduce the cubic equation to quadratic equation, we use the synthetic division. So first we have to find the one of the root by trial and error basis. After that, using that root, we can reduce the cubic equation to quadratic equation. For general cubic equation, ax cube plus bx square plus cx plus d equal to 0. According to synthetic division, first we draw like this, and then we write the coefficients here, a, b, c, d. And then we find one root, let us suppose x equal to x1. And then according to the synthetic division method, we start with 0 here. And then we find the sum of these 2, we write here. That is a plus 0, a. And then we multiply the a and x1, we write that product here. And then we find the sum of these 2, we write here. After that, again we find the product of these 2, we write here like this. It is a synthetic division method. Now, first we try to find the one of the root by trial error method. To find the one of the root by trial error method, we do like this. Our auxiliary equation is f of m equal to 0. First, we substitute m equal to 0. We check f of m equal to 0 satisfies or not. If satisfies, m equal to 0 is one of the root, and we stop there. If doesn't satisfy, then we try for m equal to 1. We check f of 1 equal to 0 or not. Suppose for m equal to 1, f of 1 is 0, then we take this as one of the root of it. Doesn't satisfy, then we take the m equal to minus 1. F of minus 1 equal to 0, then m equal to minus 1 is one of the root only. Suppose f of minus 1 not equal to 0, then we go to next root, next value, m equal to 2 like this one. By substituting m equal to 0, 1, 2, 3, minus 1, minus 2, minus 3, we check this equation satisfies or not. If this equation satisfies with any value of m, we stop there. We take that value as one of the root of the equation. And before going to check all this, first observe the coefficients. In the cubic equation, observe the sum of all the coefficients only. In the cubic equation, sum of all the coefficients is 0. Not only cubic, in any sum of all the coefficients 0, then m equal to 1 will be the one of the root only. Now here, plus 1, plus 11, plus 12, minus 6, minus 6, minus 12, plus 12, minus 12, 0. Sum of all the quotients is 0 means m equal to 1 is one of the root. Or if you substitute m equal to 1, this will become 0 only. That is why this is the root only. So up to here, we know the one of the root. With the help of this one root, we reduce the cubic equation to quadratic equation to find the two more roots only. Let us reduce the cubic to quadratic by using synthetic division method. Now till now we know the one root. We are taking that root as m equal to 1. And according to method, we draw like this. And we consider the coefficients 1, minus 6, 11, minus 6. Put 0 first here according to method. And then find the sum of these two. Sum of these two. Right here. 1 plus 0, 1. After this, find the product of these two and write this product here only. Find the product of these two only and then write here only. One plus 0 is 1 and 1 into 1, 1 plus 5 minus 6 plus 1, that is minus 5. Again, 1 into minus 5. 1 into minus 5 is minus 5 right here. Sum of these two is plus 6. 1 into plus 6 equal to plus 6. Plus 6 minus 6. Sum is 0 here. Like 1 minus 6, 11 minus 6 are the coefficients in the cubic equation. These three will be coefficients in the quadratic equation. So from m equal to 1, we write the m minus 1. From other three roots, other three quotients, we write like this. 1 into m square plus minus 5 into m plus 6 equal to 0. Now this is the quadratic equation into linear equation. It is a method of reduction, or it is a method of reducing the cubic equation to quadratic equation by using synthetic division method. So which implies m minus 1 into m square minus 5m plus 6 equal to 0. From first factor, we are getting one root, m equal to 1. From other factor, we get the two more roots as 2, 3. All the roots are real and different. Real and different. Therefore, the general solution of 1 is y equal to c1 e power x plus c2 e power 2x plus c3 e power 3x. This is the general solution. Just write the auxiliary equation, solve it for roots, and then choose the answer in the examination. Based on the roots, we write the solution on that. This is a fifth problem. Now we are going to next problem. Problem number 6. If y equal to f of x satisfies the differential equation y double dash plus 9y equal to 0, comma y of 0 equal to 0, y of pi by 2 equal to root 2, then y of pi by 4 equal to. This is the problem. Just observe this problem, compare this problem with the previous problem and find out the difference. What is the difference between this problem and first 5 problems? What is the difference between this problem and previous problems? Right. This problem is given along with the conditions. You are correct. If you observe the first 5 problems, in the first 5 problems, just a differential equation was given. But here, a differential equation is given along with the condition. It is a second order equation. This second order equation, general solution contains 2 arbitrary constants. To find the 2 arbitrary constant values, we require minimum 2 equations. To find the 2 equations, or to get the 2 equations, and after solving that, to find the C1, C2, we require the 2 equations. For getting the 2 equations, we require 2 conditions on it. So y of 0 equal to 0, y of pi by 2 equal to root 2. These two will give the 2 equations, and solving those, we can get the arbitrary constants values so that we write the particular solution. Only differential equation is given, just we find the general solution. Along with the conditions given, we can add the particular solution. But in this problem, we are not asked to find the particular solution. We are asked to find the particular value only. Using differential equation, we find general solution. Using conditions, we add the particular solution. After getting the particular solution, we add the particular value of y at a particular value of x equal to pi by 4. Finally, we require the particular value of y at some x equal to pi by 4. It is a 2 marks gate question only. It is a 2 marks gate question. And remember one point, in the first order first degree, we have discussed about 6 methods. Out of 6 methods, 3 methods were important. What are the important methods? Variable, separable, exact, and linear. Out of 3, which one is more important? That is variable, separable. So in the first order first degree, out of all the 6 methods, variable, separable is very, 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 very important. Like that, in the higher order differential equations, homogeneous differential equations is a very, very, very important. In the higher order part, we have the most of the gate questions on this homogeneous differential equations. That is, it is very, very important and simple also. Just finding the roots and writing the solution. Conditions are given. We can find the particular constant, that is our arbitrary constant value. We add the particular constant value and we add the particular solution. It is a 2 marks gate question, and it is a numerical type because fill in the blank y of pi by 4 is required. Okay, let us do this problem. First, write the given data. Given f of dy equal to 0, say this 1, where f of d equal to d square plus 9. And the conditions. Y of 0 equal to 0, say this 2, and y of pi by 2 equal to root 2. And one more thing, just observe the conditions. Based on conditions, we have two types of equations with the conditions. Based on conditions, we have two types of equation. One is initial value problem, other one is boundary value problem. What are these conditions? Are these two initial conditions or boundary conditions? Because in the syllabus, we have both initial value problems and boundary value problems. That too from second order onwards only. The differential equation with the conditions may be either initial value problem or boundary value problem. Is it initial or boundary? One of you saying that most of them are saying that boundary, right? Right. Why boundary? Already I told you. Depending on x values, we have the conditions. Here, y are given. Both are given at different values at 0, pi by 2. That is why boundary conditions. Suppose both are given at same value, then initial conditions. But here, both are y. Y means these two should be given at different values only. Y equal to 0 at x equal to 0. Y equal to root 2 at x equal to pi by 2. Y are given at different values of x. That is why these conditions are boundary conditions and the problem is boundary value problem. Whatever the problem, whether it is initial or boundary, doesn't matter. Method of finding the solution is same. Right? Now, let us start. Consider auxiliary equation. Auxiliary equation is m square plus 9 equal to 0, which implies m equal to 0 plus or minus 3i, pair of conjugate complex. Therefore, the general solution of 1 is y equal to, or y of x equal to, because y is in terms of x means y of x only. Y of x equal to c1 into cos 3x plus c2 into sin 3x into e power 0x, that is 1. This is a general solution. So this is 4. Up to here, finding the general solution is completed. Now we try to find the C1, C2 constant values. To find the C1, C2 values, we use the two given conditions. Using 2, 4 becomes. That is, using 2 means substitute x equal to 0, y equal to 0 in equation 4. And the equation becomes, using 2, 4 becomes like this. Wherever x is there, substitute 0. Wherever y is there, substitute 0. 0 equal to c1 cos 0, 1 plus c2 into sin 0, 0. So from this we can say c1 equal to 0 or c1 equal to 0. Up here we know the c1 value. Now next we find the c2 value. We apply the second condition. Y equal to root 2 at x equal to pi by 2 only. Substitute x equal to pi by 2, y equal to root 2 in the equation 4. Using 3, 4 becomes. Y of pi by 2 is root 2 equal to c1 is 0 from the previous part. So this is 0. Next to c2 into sin 3 pi by 2. That is sin 3 pi by 2 is minus 1 minus c2 into root 2. Therefore, c2 equal to minus root 2. That's, we know the c1, c2 values. If substitute c1, c2 in the equation 4, we get the particular solution. Now the particular solution or solution. Particular solution or just a solution of 1 is y equal to, or y of x equal to, y of x equal to c1 equal to 0. So first part is 0 in the equation 4. Second part, from the second part, this is minus root 2 into sine of 3x. This is one of the particular solution for these two conditions. Up here, finding the particular solution is completed. Next, we require the particular value of y at some particular value of x. Hence, y equal to y of pi by 4 equal to minus root 2 into sine of 3 pi by 4 equal to 0, pi by 4, 2 pi by 4, then 3 pi by 4. 3 pi by 4 is in second quadrant. In second quadrant, sine is positive. So sine of 3 pi by 4 is 1 by root 2. Minus root 2, 1 by root 2, it becomes minus 1. Minus 1. So finally, the answer is minus 1. It is a 2 marks gate question. Like this, we have most of the previous gate questions. So easily we can write the solution for this type of problems. Right. After this, we are going to next page. Problem number 7. If d square y by dt square plus y equal to 0 and the conditions y equal to 1 comma dy by dt equal to 0 when t equal to 0, then y is equal to option A sin t, option B cos t, option C tan t, option D cot t. If you observe this problem will be similar to the previous problem. It is similar to previous problem. Previous problem is second order, it is also second order. In the previous problem, conditions were given, here also conditions were given. Based on conditions, then one difference is there. In the previous problem, y were given at different values of x. So previous problem is bound well problem. But here y dash are given at same value of t on. Because these two conditions are initial conditions. The problem is initial value problem. Just differential equation is given along with the conditions. So we are asked to find the particular solution, not particular value only. Not particular value, not numerical value. We are asked to find the particular solution, that is function. And the previous problem was numerical type question, and this is a multiple choice question. It is also 2 marks problem. It is also 2 marks problem like previous problem. But the difference is previous one is numerical type or fill in the blank question. It is a multiple choice question. Whenever the problem is given like this, we try to choose answer by verification without doing the problem like previous one. If you want to do this problem like previous problem, we can do this problem. But here we try to choose answer just by verification. Now tell me the solution, or we do it. By verification means using condition we try to choose only. Using condition we try to choose answer if possible only. The first condition is here only. The first condition is y equal to 1 at t equal to 0. In this problem, dependent variable is y, independent variable is t only. So far we have done all the problems with dependent variable y, independent variable x only. But here independent variable is t only. So y equal to 1 at t equal to 0 only. In every option we substitute t equal to 0 and check any one option gives y equal to 1. That's all. This condition satisfies with any one option, we check it out. In first option, in place of t, if we substitute 0, then this first option will give 0, but our value is y equal to 1 only. So the condition is not satisfied with A. So A is wrong. Next, option B. When you substitute t equal to 0 in the second option, cos 0, 1, our y is also 1. So the condition is satisfied with the option B, may be answer. Even though condition satisfies with this option, we cannot stop, we cannot choose this as correct answer because more than one option may satisfy with the condition also. So let us go to the next option, tan 0, 0, but y is 1. This is wrong. Cot 0, not 1 because it is infinity. So this is wrong. Only the second option is giving 1 for t equal to 0. So condition is satisfied with option B. That is why option B is correct. That's it. So B is correct. Verification method. So the problem is given like this. Without doing the problem, just by verification, we can choose the answer. It is also 2 marks like previous one. The problem is given like previous one, then we should do the problem only. But the problem is given like this. Without doing the problem, we can choose answer. It is the advantage. Right. Next, we are going to next problem. Problem number 8. C1 e power x plus e power minus x by 2 into C2 into cos of root 3 by 2 into x plus C3 into sine of root 3 by 2 into x is the general solution of the following differential equation. Option A, dqy by dx cube plus y equal to 0. Option B, d cube y by dx cube minus y equal to 0. Option C, d cube y by dx cube plus 4y equal to 0. Option D, d cube y by dx cube minus d square y by dx square plus y equal to 0. Compare this problem with the previous 7 problems and find out the difference. What is the difference between this and previous problems? What is the difference between this and previous problems? Now, I tell you the difference. In the first 7 problems, differential equation was given and it was asked to find the corresponding solution. But here, it is purely reversed to previous 7 problems. Already solution was given here. Here we are given solution and we are asked to find the corresponding differential equation. That is, we have to check whether the given solution is a solution of any one of the option differential equation. Is it a solution of first option or second option, third option, fourth option, like this? If possible, we can choose answer by verification only, just by observation. Now observe the given general solution. It has general solution because the solution is given with a arbitrary constant, C1, C2, C3, 3 arbitrary constants. Already we have written the 2 types of solutions. One is general solution, other one is particular solution. Every solution may not be a general solution. There was a condition. In any solution, number of arbitrary constants or parameters is equal to order of the differential equation. Such a solution is called general solution. So we are given general solution with arbitrary constant. Because general solution, number of arbitrary constants is 3 means order of the differential equation should be 3 only. So our given general solution should be a solution of third order differential equation, not for second order, not for fourth order. It is a solution of third order. But in every option, third order differential equation is given, so we cannot choose. Only in one option, third order differential equation is given, directly we can choose answer. But every option is with a third order differential equation. So in this way, we cannot choose. Then we go to other method. Now observe the solution. The solution, 3 arbitrary constants were given means it is a solution of 3 linearly independent solution. One of the independent solution is exponential. Other independent solution is exponential into cos. Another independent solution is exponential into sine, like this. So this solution is a linear combination of 3 independent solutions only. Because 3 independent solutions will have 3 roots only. From the first part of the solution, C1 into e power x means it is in the form of C1 into e power mx, like this one. If you have any doubts, then I will explain the doubts in the doubt session after 4 o'clock, 4 to 4:30, in between 4 to 4:30 on. Don't worry about the doubts. C1 into e power x is in the form of C1 into e power mx. So from this, one of the root m equal to 1. Next, other 2 terms is like this, e power ax plus c1 cos bx plus c2 sin bx only. So other 2 roots are complex roots only. Suppose m1 equal to 1, m2 equal to minus 1 by 2 plus root 3 by 2, and m3 equal to minus 1 by 2 minus I root 3 by 2. These are the 3 roots. From the given solution, we write the roots like this only. Using one of the root, if it is possible to choose answer, we can choose by verification. Whenever these are the roots, these are the roots of the auxiliary equation of the differential equation, then the equation should satisfy with this one. That is, we try for this first root only, m equal to 1. For the first option, the auxiliary equation is m cube plus 1 equal to 0 only. If this auxiliary equation satisfies with m equal to 1, then m equal to 1 is the root of this auxiliary equation of this differential equation only. But when you substitute m equal to 1, this will not satisfy only. So A is wrong. For second option, auxiliary equation is m cube minus 1 equal to 0. This equation will satisfy with m equal to 1. So second option may be correct answer. We cannot choose only. Next, we go to next option, m cube plus 4 equal to 0. This equation will not satisfy with m equal to 1. Therefore, C is also wrong. And for last option, auxiliary equation is m cube minus m square plus 1 equal to 0. This equation also will not satisfy with m equal to 1. Therefore, it is also wrong. Finally, it is a correct answer. So our given general solution is the solution of this differential equation. Like this verification we can choose. Suppose more than one option satisfy with m equal to 1, then we choose answer with other roots only. This is by verification method. Next, we write the direct formula also. In the next page, we write this formula. If m1, m2, and m3 are the roots of the auxiliary equation, of a third order homogeneous linear differential equation in y, that is independent variable y, then the third order homogeneous linear differential equation in y is given by y triple dash minus m1 plus m2 plus m3 into y double dash plus m1 into m2 plus m1 into m3 plus m2 into m3 into y dash minus m1 into m2 m3 into y equal to 0. Now this is a direct format to write the general solution from the roots. Our roots were m equal to 1, m2 equal to minus 1 by 2 plus I root 3 by 2, comma, m3 equal to minus 1 by 2 minus I root 3 by 2. These are the roots from the given general solution only. So with this formula also we can choose answer only. Out of all the quotients, second term quotient is very simple. Y double dash quotient is simple. That is sum of all the roots only. If you find the sum of all these, that is 0 only. That is y double dash term is absent only. In the first three terms, in the first three options, no y double dash term only. But in the last option, y double dash term was there only. So last option is 0. That last option is wrong only. So in first three options, there is no y double dash term is first three options may be correct only. In first three options, y double dash is also means we cannot choose a correct answer with this. Then we go to the another term only. Another simple term is last term. In the last term, the quotient is product of three roots only. Product of m1, m2, m3 only. Last two are a plus b into a minus b form a square minus b square into 1. We find the product of all these, then that will be 1 only. m1 into m3 into m1 into m2 into m3 is 1. So last term will be minus y equal to 0 only. Last term is minus y equal to 0. That was present only in option B only. Minus y equal to 0. So B option is correct. Like this, we can choose answer. It is a direct formula. Okay. So with this, the problems on homogeneous linear differential equation with the constant quotients is completed on. So far, we have done the problems on homogeneous only. We are in higher order. In the higher order, we have both homogeneous, non-homogeneous only. So with this, homogeneous is completed. Now we are going to next non-homogeneous only, because always the equation may not be homogeneous, maybe non-homogeneous also. Just now we have seen only the method of finding solution for homogeneous only. Next, we'll discuss about the method of finding solution of non-homogeneous equation also. Okay, let us go to the next page. Just stop writing. If you're writing, then stop writing. Just look at this. D by dx of x cubed by 3. The derivative of this is x square. Again, integral of x square dx equal to x cubed by 3 only. D by dx, this is the derivative. X square is the derivative of x cubed by 3. And x cubed by 3 is the antiderivative. This is the derivative, then this is the antiderivative. If x square is the derivative of x cubed by 3, then x cube is the antiderivative of x square. X cube is the antiderivative of this. Suppose if I operate d by dx on both sides of this, then what will be the result? Just x square. Here we have two operators. D by dx is one operator, integral is one operator. If we operate both on the x square, the output is only x square only. Or we are using the one short form or one symbol for d by dx, that is d. D by dx, integral of x square dx equal to x square means these two are getting cancelled and we are getting x square. That is, integral is the reverse process of this. Integral is the reverse process of differentiation only. So if you use the symbol d for d by dx for integral, we use the symbol 1 by d only. D into 1 by d of x square equal to x square only. And if we compare both sides, d into 1 by d equal to 1 only. D is the operation of differentiation, 1 by d is the operation of differentiation, d by dx. Like that, 1 by d is the operation of integration, integral. So d into 1 by d equal to 1. Like this, f of d is a polynomial in d. 1 by f of d is the its inverse operator. So f of d into 1 by f of d is also 1, right? Now our non-homogeneous equation is f of dy equal to q of x. Here finding the solution of the equation is same as finding the y in terms of x satisfying this equation. So to find y, I am operating 1 by f of d on both sides of this equation. 1 by f of d into f of d, y equal to 1 by f of d of q of x. But f of d into 1 by f of d is 1. Just now above we have seen like this. So from the above, f of d into 1 by f of d is y. On left hand side, just y. On right hand side, 1 by f of d of q of x. After evaluating this, we get some function of x, and that is equal to like this, y equal to some function of x. This is the solution of this. Suppose q of x 0, q of x 0, q of x 0, y equal to 0 is a solution, homogeneous equation. Q of x not equal to 0, some function, we are getting some function. So depending on particular function in the non-homogeneous part, we are getting the one solution like this. And this solution is called particular integral or particular solution of the equation. So depending on the non-homogeneous part also, we are getting one particular solution of the equation. Such a solution is called particular integral. And it is denoted by, in short form, y suffix p on that. So for the evaluation of this, for the evaluation of 1 by f of d of q of x, we have the method on it. That is a general method. But before going to write the general method, we write the some shortcut methods for the evaluation of this based on some functions. We have many elementary functions. Elementary functions are two types: algebraic, transcendental. Polynomial, non-polynomial together are algebraic functions. Other than algebraic, transcendental function, sine, cos, that is trigonometric, hyperbolic, exponential, logarithmic only. So out of all these elementary functions, some functions we have a shortcut method for the evaluation of this 1 by f of d of q of x. So first we write the shortcut methods based on the function, and then we write the general method for any function f of x for the evaluation of 1 by f of d of q of x. So let us go to the definition of particular integral, and then we write the methods of finding the particular integral. Particular integral. In short form, P dot I. If f of d y equal to q of x is a non-homogeneous linear differential equation in variable y, then y equal to 1 by f of d of q of x is also a solution of f of d y equal to q of x, and it is called a particular integral. Pi, which is denoted by y suffix p. Therefore, y suffix p equal to 1 by f of d of q of x. For the evaluation of this, we have many methods. That's actually we have the general method, but before writing general method, we have the shortcut methods based on q of x function. So based on q of x function, we are dividing all the methods into 5 methods, totally 5 methods, where read all the different functions here. Under first method or first case, the possible functions are constant k into e power ax plus b, comma, k into sine h ax plus b, comma, k into cos h of ax plus b, comma, k into a power x. These functions come under one case. That is, for this function, we have one method. Actually, with the method is there only for this exponential function. For other functions also, we follow the same method because all other functions can be written in terms of exponential. Suppose k is given, we get the k into e power 0x plus 0. This is in the form of exponential like this. So we follow this method. Sine hyperbolic can be written in terms of exponential. Cos hyperbolic can be written in terms of exponential. And k into a power x also. K into e power log of a power x, or e power x into log a plus 0 like this. So all these functions can be written in terms of exponential. That is why whatever we have the method for this exponential, we follow the same method for other function. That is why these functions come under one case. Next, case 2. Under case 2, the possible functions are k into sine of ax plus b form, or cos of ax plus b on that. Under second case, only two trigonometric functions, sine trigonometric, cos trigonometric on that. Next, third case, polynomial function. So these are the three main functions. Next, other two are combinations of these. Other two are combinations of these. Next one is combinations of first and second. E power cx into v of x, comma, where v of x equal to k into sine of ax plus b, comma, k into cos of ax plus b, comma, polynomial on. So product of two functions here, exponential into v of x. V of x may be sine trigonometric, cos trigonometric, or polynomial function. Next, other case is product of two functions, that is x into v of x, where v of x equal to k into sine trigonometric, cos trigonometric. That's it. Only for these functions, we have the shortcut methods for the evaluation of this 1 by f of d q of x. For other functions, we use the general method. That's it. Suppose a q of x is not in the form of the first 5, then we go to the general method only. Right? For this general method, we have other alternate method of variation of parameters. After discussion of all this, we go to the method of variation of parameters. Again, remember one point. In the first order, first degree, out of 6 methods, 3 methods are important. Variable, separable, exact, linear. Out of 3, very, very important is variable, separable. Like that. In the higher order, very, 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 very important is the previous part, that is homogeneous differential equation. Like variable, separable, in the higher order, homogeneous is very, 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 very important. In the non-homogeneous, out of all these methods, these are important. First one, second one, third one. Out of these three, first one is very, very important. Till now, there is no gate question on next three. From the first three, we have the previous gate questions. From the next three, we don't have any gate question. Till now, we don't have any gate question from next three methods, these methods. We have the problems only on these three, first three only. A constant, exponential, next sine trigonometric, cos trigonometric, and polynomial. That's all. No other question from all these. So if you know the first three, we can do next two also. If you know the first three, next two also we can do. That is exponential into v, x into v only. Right? I will discuss one by one separately. The first one is case 1, second one is case 2, third one is case 3, case 4, case 5. First 5 cases are, or first 5 methods are shortcut methods, and the other method is general method. Right? Okay. Let us go to the first method, case 1. That is, we write the method for writing the particular integral for exponential on that. We're going to next page. Case 1. Here q of x equal to k into e power ax plus b on that. Only for this exponential function, we write the method on. Which first one? If f of d equal to f of a not equal to 0, then yp equal to particular integral equal to 1 by f of a of q of x. That's all. This is a formula. Suppose the non-homogeneous equation is given. In the non-homogeneous part, exponential function was given. Then we write this particular integral like this one. Just look at this, f of dy equal to q of x. From the non-homogeneous part, from the non-homogeneous part, using exponential, we are the a. That is, we find a from the exponential function. From the homogeneous part, we find f of a. Now, first we are the f of d from this, and we substitute a here. We check f of a not equal to 0 or equal to 0. Not equal to 0, directly we are the yp like this. Suppose equal to 0, then we go to next case. If f of a equal to 0, but f dash of a not equal to 0, then yp equal to x into 1 by f dash of a of q of x. This is yp. Suppose f of a is 0, then we go to first derivative. Not equal to 0, stop, write the yp. Equal to 0, we go to next case. If f of a equal to 0 and f dash of a equal to 0, but f double dash of a not equal to 0, then yp equal to, corresponding to second derivative, write the x square into 1 by f double dash of a of q of x. And so on like this. F of a is 0, not equal to 0, we stop at the yp. Suppose 0, then we go to first derivative. Not equal to 0, stop there at the yp. Equal to 0, don't stop, we go to next order. Second derivative not equal to 0, stop at the yp. Second derivative is 0, go to third order. Wherever the derivative not equal to 0, stop there, write the yp. That's all, and so on. From the non-homogeneous part, we write the a, and from the homogeneous part, we find f of d. We substitute a in f of d and check whether it is 0, not equal to 0, not equal to 0, stop, write the yp. Equal to 0, go, continue like this. This is about first method. Now we do the problems on this. After that, we discuss about next second shortcut method. So where are the problems on this? The first problem. The general solution of y double dash minus 4y dash plus 13y equal to e power 2x is, it is a second order differential equation. If you observe the left hand side terms, all terms are with a dependent variable y, its derivatives. On right hand side, there is no dependent variable, there is no derivative. This term is free from dependent variable and its derivatives. Therefore, the given equation is non-homogeneous differential equation only. Right? For this non-homogeneous differential equation, the short form of general form is f of dy equal to q of x only. Its solution is y equal to yc plus yp. Already we have seen how to find the yc. Just now we have written the method right, for writing the yp on. We find both separately and then we add. Now in the solution, we are the given equation, given f of d y equal to q of x. So this one where f of d equal to d square minus 4d plus 13 and q of x equal to e power 2x. Let us find first complementary function CF. For this, consider auxiliary equation. Auxiliary equation is m square minus 4m plus 13 equal to 0 and solve it for roots. It is a quadratic equation. Possible to write the factors, we find the factors and write the roots. Not possible to find the factors, then use the general formula of writing the roots. So after solving this, we get the roots as 2 plus or minus 3i. This pair of conjugate complex. Therefore, yc equal to complementary function equal to yc equal to e power 2x into c1 cos 3x plus c2 into sine 3x. This is a complementary function. Up to here, finding the complementary function, yc is completed only. Next, for the non-homogeneous part, we try to write the particular integral. Pi particular integral. In the non-homogeneous part, the function is exponential. Because exponential, by using the first method, we write the particular integral. Here, given q of x equal to e power 2x, we compare with the general function of case 1. Under case 1, the main function is q of x equal to k into e power a x plus b only. If we compare the general function with a given particular function, a will be 2 only. A will be 2 only. And check f of d equal to f of a equal to f of 2. That is, in f of d, replace d with a, but a equal to 2 only. F of d is d square minus 4d plus 13 only. So 2 square minus 4 into 2 plus 13 equal to. Suppose this is 0, we stop, or shall we go? If this is 0, we cannot stop here. We go to next order. If it is not equal to 0, we stop here and we write the yp here. But here it is. What is the value of this? 9 not equal to 0. Therefore, yp equal to 1 by f of a of q of x. 1 by 9 into q of x is e power 2x. This is yp. So we have both yc and yp. If we combine both, then that will give the complete solution of the differential equation or general solution of differential equation. General solution is also called complete solution. Hence, the general solution of 1 is y equal to yc plus yp. Here yc is e power 2x into c1 cos 3x plus c2 into sine 3x plus e power 2x by 9. This is the general solution or complete solution. If you are given non-homogeneous differential equation and if you are asked to find the solution, means you have to find both yc and yp. For the same non-homogeneous differential equation, if it is asked to find the only complementary function, just we find yc. For the same non-homogeneous equation, if it is asked to find the particular integral, we find only particular integral. Anyone is asked to find the solution, then we find the particular solution. Otherwise, if you are asked to find the solution, means you have to find both. Now, from next problem onwards, we try to find only particular integral, because already we know the method of finding the complementary function. So just we try to write the problems on particular integrals. Next, problem number 2. The particular integral of y power 4, that is fourth derivative, minus plus 4 into y triple dash plus 8y double dash plus 8y dash plus 4y equal to 20 is. We require only particular integral. What is the order of the equation? In this equation, highest order derivatives, this is the term with the derivative, that is fourth order derivative, fourth order equation. Here, this is a term without dependent variable y without derivatives. So the equation is non-homogeneous, and we are asked to find the particular integral. So we need to find the only yp. Given f of d y equal to q of x. So this one, where f of d equal to d power 4 plus 4d cube plus 8d square plus 8d plus 4, and q of x equal to 20. We require only particular integral. And observe the non-homogeneous part function. In the non-homogeneous part, if it is exponential or constant or hyperbolic, cos hyperbolic, or a power x, then we try to write the particular integral using the first case or first method only. Here only constant is given, so we can express constant in terms of exponential only. 20 into e power 0x plus 0. Since it is in the form of q of x equal to k into e power ax plus b. If we compare general with the particular function a equal to 0 only. Here f of d equal to f of a equal to f of 0. In f of d, replace d with 0 only. 0, 0, 0, 0, just 4 not equal to 0, stop. Therefore, yp equal to 1 by f of a of q of x. That is 1 by 4, q of x is 20. This is equal to 5. It is a particular integral. Right? It is a method of finding the particular integral. Next, we are going to next page. We are the problem number 3. The particular integral of y power 5 minus y power 1, that is fifth derivative minus first derivative, equal to 12 into e power x is. The particular integral of this is. Again, non-homogeneous differential equation. In the non-homogeneous part, we are given exponential, so we follow the same method to write its particular integral. Given f of d y equal to q of x, so this 1, where f of d equal to, because the fifth derivative we write the d power 5, next term is d power 1, and q of x equal to 12 into e power x. Since it is in the form of k into e power ax plus b, a equal to 1. Check. F of d equal to f of a equal to f of 1 equal to. Check whether it is 0 or not equal to 0. In place of, if we replace d with 1, or in place of d if we write 1, this becomes 1 minus 1, 0. Whenever it is not equal to 0, we stop, we write the yp like previous powers. But here it is 0, so we go to next order derivative, which implies f dash of d equal to, derivative of this is 5 d power 4 minus 1. F dash of a equal to f dash of 1 equal to. Since f dash of d equal to 5 d power 4 minus 1. So if we replace d with a 1, this becomes 5 minus 1 equal to 4, not equal to 0. Therefore, yp equal to x into 1 by f dash of a of q of x equal to x into 1 by f dash, that is 1 by 4. Q of x is 12 e power x equal to 3x e power x. This is the answer. If it is 0, we go to first derivative. Not equal to 0, stop. Again, first derivative is 0, we go to next derivative, and so on like this. This is about problem number 3. Next, we go to problem number 5. Particular integral of d square y by dx square plus 4 into dy by dx plus 5 into y equal to minus 2 cos hx is. It is a second order equation. In the non-homogeneous part, we have the hyperbolic function. If it is hyperbolic function also, we follow the same method. Because actually for this hyperbolic function, we don't have directly the method, but we apply the exponential method because it is written in terms of exponential. Let us solve this problem. Given f of d, y equal to q of x, so this 1, where f of d equal to d square plus 4d plus 5, and q of x equal to minus 2 into cos hx equal to minus 2 into. First, we should express hyperbolic function in terms of exponential. We should express in terms of exponential. Minus 2 into cos hyperbolic in terms of exponential is e power x plus e power minus x by 2. And after simplification, this will be minus e power x plus minus e power minus x. If you observe the first 3 problems, in the first 3 problems, the non-homogeneous part function was single function. But here, after writing the cos hyperbolic in terms of exponential, it is a sum of two exponential function only. Already we know the method of finding the particular integral for single exponential. Now it is sum of two exponential. Whenever it is a sum of two or three, like this, more number of functions, then we should write the particular integral. We should write the particular integral for each function separately, and then we add all the particular integrals. Let us suppose this sum as q1 of x plus q2 of x. q1 of x is minus e power x, and q2 of x is minus e power minus x. So for each function, we write the particular integral separately, and then we add both them. Let us consider the first one. For q1 of x equal to minus e power x. Since it is in the form of q1 of x equal to k into e power ax plus b form only. A equal to 1. Here check f of a equal to 0, not equal to 0. F of a equal to f of 1 equal to. That is, in f of d, replace d with 1. 1 plus 4 plus 5, that is 10, not equal to 0. Therefore, y suffix p suffix 1, that is particular integral 1, correspond to q1. 1 by f of a of q of x equal to 1 by 10 into minus e power x. This is yp1. And for next function, for q2 of x equal to minus e power minus x. Again, this is in the form of q of x equal to k into e power ax plus b. Here a equal to minus 1. So we check f of d equal to f of a equal to f of minus 1 equal to minus 1 square plus 4 into minus 1 plus 5 equal to, right? Plus 6 minus 4, this is 2, not equal to 0. Therefore, y suffix p2 equal to 1 by f of a of q2 of x, here q1 of x. This is equal to 1 by 2 into minus e power minus x. Hence, correspond to q of x, yp, and yp equal to yp1 plus yp2 equal to minus e power x by 10 plus minus e power minus x by 2. This is a particularity. So whenever non-obvious part is a sum of many functions like this, for each function write the particular integral separately and then add. Or at a time we can add both also like this. If it is sine hyperbolic also, like this we write this sum. It is about problem number 4. In the first problem, f of a not equal to 0. Second problem, f of a is constant, that is q of x is constant only. That is also f of a not equal to 0. In third problem, equal to 0 case, here it is hyperbolic function. Next, problem number 5. The solution of the differential equation d square y by dx square equal to e power x satisfying the conditions y of 0 equal to 1 and y dash of 0 equal to 2 is option A, y equal to 2x plus e power minus x. Option B, y equal to x plus e power minus x. Option C, y equal to 2 plus e power minus x. Option D, y equal to x plus e power x. in first four problems, just but here differential equation is given along with the conditions. It is a second order differential equation, and second order solution contains two arbitrary constants. To find the two arbitrary constants, we require two equations because we require C1, C2 values. To get two unknown values C1, C2, we require two equations. To get two equations, we are given two conditions. Again here, y of 0 equal to 1, y dash of 0 equal to 1. That is y dash are given at x equal to something, at x equal to something like this. Here, y dash are given at same value of x. At x equal to 0, at x equal to 0, we are given y dash only. Whenever y dash are given at same value of x, then the conditions are initial conditions only. At the same positions, different unknown values are given like this, initial conditions only. Suppose at two different positions, at x1, x2, at x1 y is given, at x2 y dash is given, then boundary conditions are. At the same positions, y dash are given, then initial conditions. These are boundary conditions at different positions. So it is a initial value problem only, because y dash are given at same value of x. It is an initial value problem, and in every option, particular solution is given. We can choose answer by verification also, but here we are doing the problem because of this differential equation, simple differential equation. Given d square y by dx square equal to e power x. If we observe the all problems, or if we compare this problem with the previous problems, there is one difference regarding this equation. On the non-homogeneous part, we have only single term exponential. In the homogeneous part, we have single term d square y by dx square. This is homogeneous part, and this is non-homogeneous part. Homogeneous part is contain only single term. Non-homogeneous part is contain only single term only. And look at this. Whenever this homogeneous part contains single term like this, homogeneous part contains single term, then by direct integration we get the solution without doing the problem. Without finding yc, yp separately, we write the solution just by direct integration. The number of times integration depends on the order of the derivative. It is a second order, then we integrate two times. To eliminate one derivative dy by dx, we integrate once. Again, to eliminate one more derivative, we integrate one more time only. So if we integrate two times, then we get the solution for this equation. That is a choose answer by verification method. Because we have the previous gate questions like this on this model. Now for first time integration, on left hand side one derivative will be eliminated, so that we get the dy by dx. Integral of e power x is e power x, and for first time integration, integral constant c1. Next, again once again integrate this one. Therefore, y equal to e power x integral is e power x plus c1 constant into integral of 1 is x plus, for second time integration, one more constant c2. This is the yc, this is the yp. That's all. Here c1 x plus c2, this is yc, and e power x is particular integral. If you find both also, we will get same thing only. So whenever homogeneous part contains single term like this, second order derivative, third order derivative, fourth order derivative, fifth order, any order, just by integration we can write the solution like this, yc plus yp. So up to here, writing the general solution is completed. Now we write the particular solution. Here y of 0 equal to 1. Since y of 0 equal to 1, that is substitute x equal to 0, y equal to 1. This equation becomes, this is 1, so this is 2, so this is 3. We use this condition y of 0 equal to 1 for equation 3 only. Take this y of x, substitute here with x equal to 0 only. If we substitute x equal to 0 here, e power 0, 1, 0, c2 only. which implies e power 0 plus 0 plus C2 equal to 1 only, or C2 equal to e power 0 1 1 C2 equal to 0 only. Next, y dash of 0 equal to 2 only. Since y dash of 0 equal to 2 only, from equation 2 we write the y dash, this function. Wherever x is there, in place of x substitute 0 only. Now this is a y dash of x function, e power 0 plus c1 equal to 2. E power 0 1, c1 equal to 2 minus 1. c1 equal to 2 minus 1 equal to 1. Therefore, the particular solution, or just a solution of 1 with the initial conditions, is given by y equal to, or y of x equal to, c2 is 0, second part is 0, c1 equal to 1. So e power x plus x. This is same as the option D. It is a correct answer. Without doing this problem, we can choose answer by verification also. I am doing only because of this type of equation. Because in this equation, this home x part is containing only single term. That's why we are doing. Or you can choose answer by verification. With this case 1, or first method, first shortcut method, depending on exponential function, is completed only. So we go to case 2. Under case 2, the possible functions are trigonometric functions, sine trigonometric, cos trigonometric. But second case is similar to first case method. So we are moving to next page. Case 2, under case 2, the function q of x equal to k into sine of ax plus b, or k into cos of ax plus b. In the non-homogeneous equation, whenever q of x is like this, sine trigonometric, cos trigonometric, we follow this method for writing the particular integral. In which first point, if f of d equal to phi of d square equal to phi of minus a square not equal to 0, then yp equal to 1 by phi of minus a square of q of x. Just like in the previous case, f of a not equal to 0, then yp will be 1 by f of a of q of x. Here also same. The only difference is substitution only. In the first case, we substitute a in place of d. We substitute a in place of d only. Like that here, we substitute minus a square in place of d square. It is the only difference. Just look at this, f of d equal to d plus 4 and f of d equal to 4dq plus d square minus 4, like this. In this f of d, there is no d square term only, but d square term is present in the second one. Wherever d square presents, in place of that, we write the minus a square, minus into a square. A is coming from sine function here, a from the cos function a. The quotient of x in the sine function, a is the quotient of x in the sine function, cos function. So from the sine function, cos function, we find a, we substitute minus a square in place of d square. It is the only difference. The first and second methods are similar methods. The only difference is substitution. In the first case, we replace d by a. In the second case, we replace d square with minus a square. In this method, after replacing d square with minus a square, d remains same. In place of d, we are not substituting anything only. Only in place of d square, we substitute minus a square. That's all. And we follow the same method on. Next, second one. If f of d, whenever f of d contains d square term, we take that function as phi of d square. F of d contains d square term, we take that function as phi of d square. After that, in place of d square, we write the minus a square. We check whether it is 0 not equal to 0. Suppose this is 0, then we go to first derivative. F dash of d equal to phi dash of d square equal to phi dash of minus a square equal to 0. Sorry, here not equal to 0. Then yp equal to x into 1 by corresponding to first derivative, we write the x into within the brackets 1 by phi dash of minus a square of q of x. This is yp. Suppose this first derivative is also 0. We go to next derivative. Not equal to 0. Stop there at the yp. Equal to 0. Continue like this. That is why it is similar to previous. Only substitution is different on. Third one. If f of d equal to phi of d square equal to phi of minus a square equal to 0, and f dash of d equal to phi dash of d square equal to phi dash of minus a square equal to 0, but double dash f double dash of d equal to phi double dash of d square equal to phi double dash of minus a square not equal to 0. Then yp equal to yp equal to corresponding to second derivative, write the x square into 1 by phi double dash of minus a square of q of x. Like this. Suppose this is also 0, we go to next derivative and so on. Like this, we continue like this. Is a method. So first and second methods are similar methods except one difference, except substitution only. That is, for first method we replace d with a, in the second method we replace d square with minus a square. It is the only difference. In both cases, a is the quotient of x in the function. And we write the note point. Point 1. D of f of x equal to d by dx of f of x. Or here we take the q of x. Next, d square of q of x equal to d square by dx square of q of x. D cube of q of x equal to d cube by dx cube of q of x, and so on. Next, note point number 2. One by d of q of x means here integral of q of x dx 1 by d square of q of x equal to integral of q of x dx 1 by d cube of q of x equal to integral q of x dx and so on. This is the operation of differentiation. 1 by d is the operation of integration. Remember this. So let us go to the problems for this. Problem number 1. First problem. The particular integral of d cube y by dx cube plus 4 into dy by dx equal to sine 2x is. It is a third order differential equation, that is non-homogeneous equation. In the non-homogeneous part, we have the trigonometric function. Whenever it is sine trigonometric function or cos trigonometric, we try to find the particular integral by using second method on. So let us do this problem. Given f of dy equal to q of x, so this 1. Where f of d equal to d cube plus 4d and q of x equal to sine 2x. Whenever it is sine trigonometric, cos trigonometric, we check f of d is containing d square term or not. But in this f of d square is present because we write the d cube as d into d square plus 4d. D into d square. If d square term presents, then we consider this as function of d square. It is a function of d square. Whenever f of d contains d square term, we take this as function of d square. So first we check f of d equal to phi of d square. And we are replacing d square with minus a square. When you compare the given trigonometric function with the general function, q of x equal to k into sine of ax plus b, a equal to 2 only. A square is 2 square. Minus a square is minus 2 square. So phi of minus 4 equal to, or let us write the 2 square only. So in f of d, in place of d square, write the minus 4. That is d into minus 4 plus 4d. Minus 4d plus 4d. This is 0. So whenever phi of minus a square is 0, we go to next derivative, which implies f dash of d equal to phi dash of d square equal to phi dash of minus a square equal to phi dash of minus 2 square equal to. First of all, for this derivative is f dash of d equal to phi dash of d square equal to derivative of this is 3d square plus 4. That's all. So replace d square into minus 4. 3 into minus 4 plus 3. So plus 4. Minus 12 plus 4, 8 minus not equal to 0. So whenever first derivative is not equal to 0, we stop. We are the yp on. Now yp equal to corresponding to first derivative x into 1 by phi dash of minus a square of q of x. Which implies yp equal to x into 1 by minus h into q of x is sine 2x. Therefore, yp equal to minus x into sine 2x divided by 8. This is the yp, particular integral. This sine trigonometric, cos trigonometric, we follow this one. Whenever first one is 0, that is phi of minus a square is 0, we go to first derivative. Not equal to 0, we stop, we write the yp like this. This is problem number 1. Next, problem number 2. The particular integral of y double dash plus y equal to cos x is again, it is an anomalous equation. In the anomalous part, the function is cos trigonometric. So we do this problem also like previous one. And write the solution given f of d y equal to q of x. So this one where f of d equal to d square plus 1. In f of d, d square is present. So we take this as function of d square, phi of d square. And q of x equal to cos x. The cos function, quotient of x is 1. So a equal to 1. So first we check whether it is 0, not equal to 0. If f of d equal to phi of d square equal to phi of minus a square equal to phi of minus a equal to 1. So minus 1 square, that is minus 1. In f of d, in place of d square, write the minus 1. That is minus 1 plus 1 equal to 0. If it is 0, go to first derivative. Its derivative is f dash of d equal to phi dash of d equal to 2d. That's all. So f dash of d equal to phi dash of d square equal to phi dash of minus a square equal to phi dash of minus 1 square equal to just 2d. There is no d square to substitute minus 1 in place of d square. If d square is present, then only we replace this with minus a square only. If d remains, we never substitute anything. So replace d square with minus a square and d remains same like this. And this is not equal to 0. So stop like previous one only. Write the yp. Now yp equal to 1 by, that is first one. Correspond to first derivative, we write this as yp equal to x into 1 by phi dash of minus a square of q of x equal to x into 1 by 2d. Q of x is cos x. In the first problem also, f dash is not equal to 0. Here also f dash not equal to 0. That is phi dash not equal to 0. But the difference between previous and this is, in the previous problem, no operator. Just we go back. So after find the derivative, directly we got value minus 8 only. But in this problem, after find the derivative, we are getting 2d. That is in the denominator we have an operator. In the previous problem, no operator, just constant. That is why we stop here. If the operator is present like this, we should operate this on this function only, which implies yp equal to x by 2 into 1 by d of cos x. Already we know that d means operation of differentiation, 1 by d means operation of integration. 1 by d means integral. So one time integral. Therefore, yp equal to integral of cos is sine. So x into sine x divided by 2 onwards. Right? Like this we do one. Suppose there is no d. There is no d. Here we have 1 by 2d cos x. And if there is no d, just 1 by 2 cos x is the final answer. Right? Now we do one more problem and then we stop. After that, we will discuss about doubts. Let us do one more problem. With that, this method will be committed. That is, we do one more model problem. Problem number 3. last problem for today's class. After this problem, I will close the session. The particular integral of y triple dash y triple dash plus y equal to sine 3x is. It is also non-homogeneous equation, third order equation, non-homogeneous. In the non-homogeneous part, we have a sine function. If it is sine trigonometric, cos trigonometric, we follow the same method. Let us do this problem. Given f of d y equal to q of x, say this one, where f of d equal to dq plus 1 and q of x equal to sine 3x. Since it is in the form of q of x equal to k into sine of ax plus b formula, a equal to 3. Check f of d equal to phi of d square equal to, here 1 plus dq means d into d square. This is equal to phi of d square only. So phi of minus a square equal to phi of minus, in place of a 3, a square means 3 square, minus a square means minus 9 or minus 3 square equal to. In f of d, wherever d square is present, in place of d square, write the minus 9. So 1 minus 9 d only. And this is not equal to 0. So write the yp. Now yp equal to 1 by phi of minus a square of q of x is equal to 1 by 1 minus 9d. Q of x is sine 3x. In the previous problem, operator was there. Here also operator is there. Whenever we have a single term in the denominator, directly we can operate it. That is 1 by d means integral only. But here in the denominator, we have a difference of 2 terms. If we have a more than 1 term in the denominator, directly we cannot operate. That is, we cannot integrate on. So here we try to get d square term. To get the d square term, we rationalize this. We rationalize this part. That is, we rationalize the 1 minus 90. For rationalization, we multiply divide with its rationalizing factor 1 plus 9d only. To get the d square term, we should rationalize this sum. This is equal to 1 by 1 minus d. The rationalizing factor of 1 minus 90 is 1 plus 90. This process is called rationalization. Only for getting d square term, we are doing like this. Because for sine trigonometry, cos trigonometry, we replace d square by minus a square, which implies yp equal to 1 plus 9d divided by 1 minus 81 d square of sine 3x. Now we can operate any one first. We write this in 2 ways. 1 plus 9d into 1 by 1 minus 81 d square of sine 3x, or 1 by 1 minus 81 d square of 1 plus 9d of sine 3x. Whatever you choose, we get same answer only. Let us choose the first one. First, we operate the 1 by 1 minus 81 d square on this. Same as problem number. That is, this is same as second case only, sine trigonometry. Just replace d square with the minus a square and check whether it is 0, not equal to 0. This is not equal to 0. Directly we write the value. Yp equal to 1 plus 9d 1 by 1 minus 81 into d square. In place of d square, minus 9 of sine 3x. So this is completed. This is evaluated only. On the resulting function, we operate 1 plus 90. We operate the 1 plus 90 on this function. Therefore, yp equal to 1 into this function. This 1 by 730 2 730 of sine 3x plus 9 into 9 by 130 into d of sine 3x. Derivative of sine 3x, that is sine 3x divided by 730 plus derivative of sine is cos into 3, 927 by 730 into cos 3x. So if we have a like this binomial term, then we should rationalize. After rationalization, we get the d square term, and then we do the problem like this. This is another model for sine trigonometry, cos trigonometry. So with this, the two methods for finding the particular integral is completed. We have completed. We have the 5 shortcut methods, 1 general method. Out of 5 shortcut, 2 shortcut methods are 2 shortcut methods are completed only. Out of 5, 3 shortcut methods are important. Out of 3 important, 2 are completed only. So with this, we close the session, today's session, and we continue this tomorrow. Okay. Right. After this session, we have a doubt session up to 4:30. If anybody has doubt, we can ask. Otherwise, we can take rest. Take the break up till next class. Let us start the doubt session. Hello? Hello?
Good evening, sir.
Good evening. Tell me. What is your doubt?
Good evening, sir.
Good evening.
Sir, page number 8.
Page number 8. Okay.
Good evening, sir.
Good evening. Okay, we are going to page number 8. Tell me. What is your doubt here?
Page number F, what you told actually.
Page number.
Sir, actually I didn't understand the question itself.
Which question?
Part I understood, but the Y part where also is there, but in between them I lost the connection. Actually my connection was low, so I could not get you.
Have you received the class material, that PDF material? Hello?
No, sir, this question I did not understand.
Only this.
Hello?
Question? Only this question?
Hello?
Hello? Only this question?
Yes. Yeah. Actually, in middle part my connection. Yes, sir. Only this question.
Okay. We are going to the question only. This is the page number 8. So we are going to actual question. This is the actual question. In this question, directly general solution is given.
Okay.
General solution is given. C1 exponential plus e power ax into c cos trigonometric plus c sin trigonometric. This general solution is contained in 3 arbitrary constants, C1, C2, C3. Because of 3 arbitrary constants, it is a solution of third order differential equation. Right? General solution means number of arbitrary constants in the solution equal to order of the differential equation. Suppose in every option.
Okay, sir.
Is it okay? Hello? Doubt is clear?
It's okay, sir.
Okay.
No, sir. In the question I didn't understand.
Which one? Same question?
8F. Sir. Actually, that question, main question is this one only.
This is the main question only. Actually, we are asked to find a corresponding differential equation.
So, how to get the solution?
Do you want
yes,
to find?
Sir, yes.
Already solution is given.
So, you told.
Hello?
Sir, I understood the last part that for to check the y part you told me, sir, at last. Means minus y is there.
Right.
That part I understood. Sir, in middle what you told actually I lost the connection. That is why I could not hear.
Okay,
That's
I
why
repeat.
I asked you this question.
I repeat it. Actually, we are given solution. We are asked to find the corresponding differential equation. Because options, we can choose answer by verification only. Right? Now, from this general solution, the first term is C1 e power x only. This is corresponding to one of the root. It is in the form of C1 e power mx. So, in place of m, we have the root 1. M equal to one of the root only. And this m equal to 1 is the root of the auxiliary equation for the differential equation. That is why for every option, we have written here auxiliary equation.
Yes, sir. Yes, sir.
If any one of the auxiliary equations satisfies with this root, that is the solution only. But first option, third option, last option will not satisfy with this. Only second option, auxiliary equation will satisfy with m equal to 1. That is why this is a correct answer, please. Suppose more than one option, more than one option satisfy with this root, then we go to other two roots only. Okay?
Sir.
Is it okay?
Yes.
Do you have any other doubt? Only
Yes, sir. Yes, sir. Last doubt, sir. In the last method that you taught today, sir, if for example means
last problem you are talking about.
Yes, sir, last one. Hello.
Tell me.
Hello.
Tell me.
Sir, in that last YP, if in case of last question, sir, last question.
Okay, this is the last question actually.
If in place of one, yes, sir. In here, in place of YP, that is equal to 1 by 1 minus 9D into sin 3x.
Yeah.
If in case for some question it is 1 by only 9D square, so in
9D square means
put the minus a square and write the.
Yeah. If it is only 9D square, we can put.
No need to integrate. No need to.
In two ways we can do only.
Sir, okay. So no, in that case, no need to. So in did not go for.
Hello,
sir. So that you can directly put the value and get the answer. No need for double in.
If you want to integrate, you can integrate, or we can substitute directly minus a square value in place of d square only. Any one we can do only. We can do in integration method, or we can do this problem by substitution also. Any one we can do. Got it?
You will get the same answer.
I will get same answer.
Yes, sir. Will get. Okay, sir. Okay. That's all. Thank you.
Hello.
Hello.
Tell me, what is your doubt?
Clear, sir. Hello. Hello.
I am audible. Your voice, I'm able to hear your voice. Are you able to hear my voice? Hello. Hello.
Good evening.
Good evening. Tell me your question. Hello.
Sir, good evening, sir. Sir, in page number 3F.
3F, okay.
Sir, have you read the general solution, sir? Last step.
Last one.
Yes, sir.
Actually, only suppose m square plus 1 is two roots, 0 plus
Ah,
I. These two are complex roots only.
yes, sir.
But the two are repeated. How many times repeated? 2 times repeated.
2 times.
Corresponding to 2 times repeated. In place of arbitrary constant, we write this C1 plus C2x.
Okay, sir.
Other constant C3 plus C4x.
Okay, sir. Page number 5.
Page number
5F.
okay.
Sir, it is also, we can say that it is also initial conditions, na, sir? You say that it is a boundary.
No, only boundary conditions, boundary value problem. Because both are given at different values of
Values
x.
of x. Okay, sir.
Boundary conditions.
Sir, another doubt, sir. Last two problems you solve, na, sir. In that, if the d is in denominator, we can integrate, and if the d is in numerator, we can differentiate it, right, sir?
Right, correct.
Okay, sir. Thank you, sir.
Next, we are going to. Hello.
Hello.
Ask your turn.
Sir, 5F.
Which page?
5F, sir.
5F. Okay.
Sir, you are told that if m equal to complex, it is a cos C1 plus C2 cos x, no, sir.
C1 cos x plus C2 sin x. That is
No, sir. A cos x plus B sin x, it no, sir.
A plus or minus IB. So in place of that, we can add the like this only. E power AX into A cos BX plus B sin BX. That capital A, capital B or arbitrary constant. Instead of that, capital A, we can add any one, C1 or capital C1, any one we can add, no problem.
Okay, sir.
While writing the procedure, already have taken C1, C2 in the one of the form of the solution. So without getting any confusion, I wrote there other constant A only. That is the only difference.
Okay, sir. Sir, 15F.
Tell me.
Sir, here we can solve the answer by direct verification of options, no, sir.
Using conditions also we can verify. By
Yes, sir.
using one condition, if it is possible to choose answer, we can choose. Not possible, we can use other condition, y dash condition.
Yes, sir.
Okay.
Okay, thank you, sir.
Hello.
Hello, good evening, sir.
Good evening.
Sir, 8F.
8. What is your
Sir, if two options are correct, how we need to check this, sir?
we have to verify all the quotients. First, suppose if you take the second term, by using the sum of three roots, we can verify it. Or by using the last quotient also, we can verify it. If these two are same, then we can verify the using the third term quotient, sum of the products of two roots.
Like we need to multiply M2, M1, M2, M3, then if you get negative. That.
Actually, we can choose answer with only one quotient or two quotients only. We need not to go for other quotient.
How, sir?
Suppose in the options, second derivative quotient is same in two options. And the last term quotient is also same. When second term quotient, last term quotients are same, directly we can verify the sum of the products of two roots only.
Okay. But in previous slide, sir, in previous slide, the options are given like
this.
Yes, sir. In this, only second option having minus y. That's why we are choosing that answer, sir.
Yeah. Because if you add this, first simple term is sum of the three roots only.
Yes,
sum
sir.
of three roots is 0. So second term is 0. That is y double dash is 0. That is absent only in three options. Directly last option is eliminated. Got it?
Okay, y double dash is not there.
Not there. That is why we are going to last term quotient only. Last term quotient is product of three roots only.
Okay. Got it, sir. Got it. Sir, one more doubt is 14.
14F.
Sir, this method comes under first category, right, sir?
First category.
They have given in question cos h of ax, sir. I will put directly a value in
No,
solution, sir.
Actually, we don't have the method for cos hyperbolic directly. We have the method only for exponential. That is why we have written the method only for cos of ax plus b on. Sorry, e power ax plus b.
Okay, for cos h and sin h, there are no formula, sir.
No formula. Directly, we should express this in terms of exponential, and then we follow the exponential method for this also indirectly.
Okay, because in second category you directly took a. That's why I got confused. Like we can't take a
trigonometric, only trigonometric. This is only hyperbolic.
Hyperbolic. Okay, sir. Thank you, sir. Sir, hello.
Hello. Tell me.
Sir, probability also you won't take, sir?
No, I am not taking. Actually, I won't take probability. Except probability, I teach other topics.
Okay, okay.
I won't teach only probability.
Okay, sir.
Okay, except probability, I teach other topics, all other topics.
Okay, sir. Thank you, sir.
Hello.
Sir, one small doubt, sir. First slide.
First. Okay. Is it a first slide?
Yeah, sir. In that, in YC, first we get C1 e raised to 2x plus 10, that equation, no? To that second equation, how we were converting, sir?
I have attended the previous class, Friday class.
Yes, sir.
Yesterday, in the last class, I have shown how to convert the exponential in terms of hyperbolic. Okay, I will give the hint here. Sin h a x equal to in terms of exponential e power x minus e power minus ax by 2. Cos h a x equal to e power ax plus e power minus ax by 2. Okay. Now, if I write the cos h root b x equal to e power root b x plus e power minus root b x by 2. Next is sin h root b x equal to e power root b x minus e power minus root b x divided by 2. This is cos hyperbolic, this is sin hyperbolic. Okay. If I add these two, negative power terms will get cancelled. Only will get the positive power terms. E power plus root bx by 2. Here also e power plus root b by 2. Finally, we get the 2 times by 2. 2 to get cancelled. E power root b x equal to cos plus sin. Suppose if I subtract this minus this, cos h minus sin h. When you subtract these two, positive power terms will get cancelled. We get the negative power terms on e power minus root b x equal to cos h root b x minus sin h root b x. If I multiply c1, 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 here c2, c2, c2. If I add these two, c1 into e power root b x plus c2 into e power minus root b x equal to, on right hand side, from these two terms, cos hyperbolic is common. From these two terms, sin hyperbolic is common. So c1 plus c2 into cos h into root b x plus c1 minus c2 into sin h root b x on. C1, C2 are constant. This is also some constant. Again, C1, C2 are constant. This C1 minus C2 is constant. I am writing this as capital A into cos h root b x plus some other constant b sin h root b x. Got it?
Yes, sir.
We can express this exponential in terms of like this one. This into e power ax. E power x is common from both. So we have the e power x into 1.
C1. Okay, sir.
Because when you multiply with e power x, this becomes e power a plus root b x plus c2 into e power a minus root b x. Got it?
Yes, sir.
Okay. Only this doubt?
Yes, sir. Got it.
Hello? Hello?
No.
Tell me your
Good evening, sir.
good evening.
Sir, actually, I'm a little confused. That means there are shortcuts and there are also methods to solve one question. So when I started doing a question, then I spent some time thinking, should I do with that long cut method or the shortcut one? So what should I do?
Regarding which problem, which method?
So like today you were telling about that
Okay.
solution was given and we have to options in the options that derivative form was given.
Now, based on problem, we do the method on. We do the problem by some verification method or final method on. Now, if we
Sorry, sir.
just a differential equation is given, just a differential equation is given without conditions. Okay, we should do the problem by method. Got it? Hello?
Okay, okay, sir. Yes, sir.
Suppose the differential equation is given along with the conditions, and also options are given. That is, in the options only particular solution is given. Then in such case, we can choose answer by verification method only. By using condition, if it is possible to choose answer, we can choose. Not possible, by using differential equation also, we can choose answer only. So whenever initial conditions are given, we try to choose answer by verification only. Got it?
Okay, sir. Sir, so while doing question, should I go for that short trick or should I do the whole method for practice?
The shortcut method is possible, then you do the problem by shortcut method only.
So there are questions like the differential equation of the family of curves of the form like this, family of circles, family of curves. We have to do such type of questions.
No, not required, not required. Actually, general solution, I will tell you. Suppose if we consider the first order and first degree, f of x, y, y dash. This is the first order differential equation. The first order differential equation general solution contains only one arbitrary constant. That is f of x. Its general solution will be in the form of f of x, y, c, 1 equal to 0. For particular value of c, we write the particular solution. G of x, y, some particular value. Let us suppose this is 2 equal to 0 only. This general solution represents the family of curves because solution is here y equal to f of x only. It is a curve only. With the arbitrary constant, it is a set of curves. For C1, we get one curve. For C2, we get one curve. So that is why this is called family of curves only. Particular solution is one particular curve. So geometrically, the general solution is a family of curves. And the particular solution geometrically is a particular curve, one curve, single curve.
So in question it is given y is equal to ax plus bx squared, and there are four options. Should I tell?
You can tell your question.
So the question is the differential equation of the family of curves of the form y is equal to ax plus bx squared is
Y equal to
ax plus bx squared.
ax.
X squared.
ax square.
No, sir. Bx squared. Then there are some four options. X square y double dash minus 2x y dash.
X square y double dash
Minus 2x y dash.
Okay.
Plus 2y.
Okay.
Is equal to 0.
Okay.
In the second option, there is the second term plus 2x y dash. First option is same. First term is same. First and third term is same.
For this type of problems, we can do one thing. By verification, we can choose answer. Because already this is a solution. This is a solution. We are asked to choose the differential equation.
Yes, sir.
You do one thing. Substitute y, y dash, y double dash. And check LHS part equal to RHS part or not.
Okay.
That is the best thing. Got it?
Yes, sir. So there is one more question.
Ah,
The solution of dy by dx is equal to sine x plus y is.
sine of x plus y.
Yes, sir.
Now it is a first order.
Variable separately.
It is a first order and first degree differential equation.
Yes, sir.
Next, on right hand side, this is a function of x and y.
Yes, sir.
F of x comma y equal to sine of x plus y. But it is not in separable form directly. But indirectly we can separate it because sine is a function of linear expression x plus y. If we replace x plus y with some other variable z, then we can make it separable form only. X plus y.
Yes, I have done that. So, but I couldn't get the option. So I have done that, but I couldn't get the option. So can you please do this?
Only calculation part. This becomes okay. 1 plus dy by dx equal to dz by dx. So dz by dx equal to minus 1 sine z. Dz by dx equal to 1 plus sine z. Integral of 1 by 1 plus sine z. dz equal to integral of x.
Sir, options are in tan and sec. Means it's like tan x plus y minus sec x plus y is equal to x plus y like this option.
Are you getting this one in the denominator? Integral of 1 by 1 plus sine z. Did you get the same thing?
Yes, sir. Yes.
Okay. Now, cos 2 theta equal to 2 cos square theta minus 1 or 1 minus 2 sine square theta. Right?
Yes, sir.
And this is sine only. We cannot write this as sine z.
So should I tell you the options?
Tell me.
Tan x plus y.
Wait. Tell me.
Tan x plus y
Tan of x plus y
minus sec of x plus y is equal to x plus c.
equal to x plus c.
Second option. Yes.
Uh,
Sec x plus y minus tan x plus y.
sec x plus y minus tan
X plus y is equal to x squared by 2
x square by 2
plus c.
plus c.
Third option, tan x plus y
Tan of x
minus
uh,
cos x plus y
cos of x plus y
is equal to x plus c.
Equal to x plus
C.
c. Okay.
And fourth option, in place of cos, just write cot.
In place of cos, sine.
Cot.
Cot. Okay. Only we have to integrate this 1 by 1 plus sine z. Actually, one method is here. We can write 1 as sine square theta plus cos square theta, but that depends on the sine function. Sine 2 theta equal to 2 sine theta into cos theta. Sine theta equal to sine theta by 2 plus cos theta by 2. Okay.
Write like sine square theta by 2 plus cos square theta by 2 plus 2.
Sine theta by, sine z by 2 cos z by 2, and in place of 1 we write the sine square z by 2 plus cos square z by 2 only. Then we can add the sine plus cos whole square, a plus b whole square formula. Okay. And we have to integrate this one. So after simplification, we get it like this. Only integration part done. You are not getting only this only integral part. Huh?
Yes, yes.
Okay, I'll do one thing. Tomorrow I will do it here on. Okay. Any other doubt?
No, sir.
Hello?
No, sir. Thank you.
Okay. Hello? Hello?
Sir, I've asked the question.
Okay, okay. Hello? Hello? Hello?
Hello.
Ask you that.
Yeah, yeah. Last.
Last slide.
Yeah, last.
This one.
Sir,
Last
any method will get. Yeah, any method we'll get two probabilities. No, sir. After rationalization,
Ah,
anyone will get the same answer only. No, sir.
same answer. Sometimes you may get different
Yeah.
one constant.
Sir, can I?
Actually, in general, we'll get same answer. Sometimes both will differ by only just constant. Constant doesn't matter. Constant will go to the particulars, complementary function.
Okay. Sir, can I get your contact details?
9848
Yes, sir.
90
Yes, sir.
5004.
5004.
Right, right.
Yeah. Thank you, sir.
It's a WhatsApp number.
Yeah. Okay, sir.
Hello? Hello? Okay, I'm closing the doubt session also.